Hi, in this session we are going to discuss about process scheduling of process in operating system. Under process scheduling we are going to discuss about scheduling queues, CPU scheduling and context switch. Now, first we know about what is process scheduling, how the process are going to be scheduled in the CPU. Before that we have to be very clear about two things, multiprogramming and time sharing. So we know that we are having lot of process. For example, P1, P2, P3. I may have some P1, P2, P3 and Pn. Lot of processes are available in a system. So for a CPU, what is the objective of multiprogramming? To maximize the CPU utilization. So to maximize the CPU utilization, what I have to do? To have some process running at all times. That is, at any time the CPU should be utilized to the most. So either it is P1 or P2 or P3, any one process should be assigned to the CPU at any particular time so that I can maximize the utilization. And what is the objective of time sharing? Time sharing is that one process cannot hold the CPU all the time. So I'm going to share the resources such that, for example, first P1, then some duration for P2, then some duration for P3. Again, I can share it for P1. Like that, I can share the timing of CPU to each and every process. That is going to equally, I'm going to distribute the CPU resource to every process. So what I need to do that, I need to switch a CPU core among the existing processes frequently. In order to that, the user may think that I am able to work with multiple processes at the same time. For example, if I'm having nowadays we are having quad core, dual core process where we are having two or three or four processes. But earlier days we are having a single processor, a motherboard containing single process. But what we'll think, we are able to work a word processor, I'm able to work a browser at the same time. I am thinking that both are able to work on the same time. But the fact is, at one particular point of time, either word is working or my browser is working in the CPU. But they are switching one another in the way that for the user we have the feel that all are working on the same time. So the objective of multi-programming is to maximize the CPU utilization, whereas the objective of time sharing is to switch the CPU core. So what we are going to do among these two? So for this, having these two objectives in the mind, to meet these objectives, what I need to do? I need to have a process scheduler. So what is the role of process scheduler? The scheduler will select an available process for a program execution on the core. Core means processor. So where if it is a single process, no issue. I can allocate to the processor directly. But if I'm having a set of available processes ready for execution, the process scheduler will choose one process and make it to the running mode. Which one I am going to make it from ready state to running state? That is the core point here. So each CPU core can run one process at the time. There is CPU processor. One processor can run one process at a time. If I'm having a single CPU core, there is no other thing that one process can run at a time. But if I'm having a multi-core system, multiple processes can be run at one time. By having that, each CPU will be allocated with one process at a time. Now the question is, if I am having more number of processes ready for execution, which is greater than number of cores. That is, if I am having only three processes, but I am only two cores. Available CPU is two, but I am having three processes. How I am going to do? So of course, absolute solution is the excess process have to wait until a core is free, until it is rescheduled. So when there is more number of process, it is a fact that the process has to wait and be rescheduled. So the number of processes currently in memory in active mode, it is called as degree of multiprogramming. So to have that degree of multiprogramming, we have to balance the objective of this multiprogramming and time sharing. So to have that, what I need to do, we have to observe the behavior of a process. What are the behavior of a process? We should know that some processes are either IO bound or some are CPU bound. For example, I'm going to type a resume or I'm going to type a OS notes. I'm keep on typing. So I'm keep on engaging with my keyboard. I'm going to print the notes. I'm going to engage with my printer. I'm engaging my input device. I'm engaging my output device. So this process has to be IO bound because the process spends more time of its time doing IO than it spends with computation. But whereas I am having a program where I am having a database of all the students and their marks, I am going to generate the grade sheet for the students. I am going to click the generate button. The CP is going to get the mark of all the students and calculate who are all going to be A grade, O grade, first class, second class. It generates the grade sheet. So it is not spending more time on IO. It spends more time on its CPU. So here it is sent to be CPU bound process.